What if I told you that information isn't just something you read or watch, but an actual physical force? A force that could literally be used to engineer reality? Well, a brand new field called vacuum coherence engineering is proposing exactly that. And its very first test is a deceptively simple experiment that's trying to answer a huge question.
Yeah, it all boils down to this. One simple, almost poetic question. Can a sound wave tame a chaotic jet of water? I mean, can a specific vibration turn a messy, random splash into a perfectly smooth, stable stream? It honestly sounds a little like magic, but this experiment is designed to test a truly radical idea about how our universe works.
Because you see, the water is just the beginning. What's really being tested here is a much, much bigger idea. The team behind this is trying to prove that information isn't just, words or data that describes things. They're proposing that it can be an active, physical force, a tool you can use to build stability and order directly into systems that are normally chaotic.
And that brings us to the official name for this whole new field, vacuum coherence engineering, or VCE for short. The core idea is that information can act like a stabilizing field to extend what's called coherence, which is really just a physicsy way of saying order and stability. Now, the grand vision here is to someday apply this to the quantum vacuum of space itself. But you gotta walk before you can run, right? You have to start somewhere a lot more manageable. So, how in the world do you even start to test a mind-bending idea like this? Well, you don't blast off into space. You start right here on Earth, with plain old water. It turns out it's the perfect proving ground. It's a big macroscopic system that we can easily see and measure to test a really fundamental theory.
Okay, so any fluid, like water, can basically be one of two things. On one hand, you've got smooth, orderly, laminar flow. Just picture a perfect glass-like stream coming out of a faucet. And on the other hand, you have chaotic, turbulent flow, that messy, splashing chaos. The whole idea here is that tiny little instabilities are what cause that flip from order to chaos. And this experiment, it's designed to fight back.
And this is why water is just the perfect choice for the job. You can see it, you can measure it, but most importantly, this experiment is falsifiable. That's a huge deal in science. It just means it's designed to give a clear yes or no answer. Either the information stabilizes the water, or it doesn't. There's no hiding from the result.
Now, to pull this off, you can't just grab any old garden hose. Nope. You need a very special tool, a custom-designed instrument that is really the hero of this entire story. So let me introduce you to the Δ-Nozzle.
This thing is just a beautiful piece of engineering. Its inside shape follows what's called a cosine-bell curve, which is basically the smoothest possible profile you can have to prevent turbulence right from the get-go. But here is the secret sauce, an integrated piezoelectric actuator. That's a fancy term for a little component that vibrates when you run electricity through it. It allows the researchers to inject a super precise sound wave, the information, directly into the water flow.
Okay, so we've got our instrument. Now it's time for the actual coherence test. And the goal here isn't just to make the water a little bit smoother. No, they're hunting for something very specific, a resonance frequency, a magic frequency that will dramatically, and I mean dramatically, amplify the stability of that water jet.
And this quote from the research paper, man, it just says it all. It says that coherence, that order and stability, isn't just something that randomly happens in nature. It's an engineerable quantity. Think about that. Just like we can engineer a bridge to be strong or a circuit to be efficient, VCE is suggesting we can engineer a chaotic system to be stable. And the way they test this is just elegantly simple. 3 steps. First, you get your baseline. You just measure how long the water stream stays smooth all on its own before it breaks up into chaos. We'll call that L0. Step 2, you turn on that actuator and you sweep through a whole range of sound frequencies. And finally, step 3, for every single frequency, you measure the new and hopefully longer stable length.
So the entire experiment, all this work, all this theory, it all boils down to one single number, the coherence factor, which they call lambda. And it's a really simple ratio. You just take the new, stabilized length of the water jet, and you divide it by the original natural length. That's it. If that number is big enough, they've done it.
So what's the magic number? Well, they're not messing around here. Success isn't just a tiny improvement. To prove their hypothesis, they're looking for a coherence factor of 2 or more. That means they have to at least double the stable length of the water jet. That is a high bar, and it's exactly what makes this a real, meaningful test. And here's exactly what that looks like. If the natural passive flow stays smooth for, let's say, 15 centimeters before it falls apart, then a successful driven flow would need to stay smooth and stable for at least 30 centimeters. That's the visual proof right there. That's what success looks like.
And here is the key prediction, the really cool part. They don't expect a gentle, gradual improvement across all the frequencies. The theory says there should be a specific magic window of frequencies where the stabilizing effect will suddenly and sharply spike. Finding that sharp, nonlinear spike on their chart, well, that's the smoking gun. That's the definitive proof they're looking for.
All right, let's zoom out for a second. Let's say it works. They find the resonance, they double the length of the water jet, they pop the champagne. What does that actually mean for the rest of us? Well, it could signal the beginning of an entirely new frontier in physics.
A successful result would be absolutely profound. First off, it would prove that information can be used to directly stabilize a chaotic system. Second, it means turbulence isn't just some random force of nature we have to put up with. It's something we can actually control, or at least influence. Third, this simple jet of water would become a real-world model for how coherence might work at the quantum level. And finally, it would give this whole new VCE framework its first and most crucial piece of experimental validation.
And this final quote really gets to the heart of what makes this such good science. It's not just some wild idea cooked up on a whiteboard. It's a testable one. It's simple enough that other labs can reproduce it, and it's designed so that failure would be just as informative as success. This is exactly how new fields of science are born. And so that leaves us with this final, tantalizing question. If a simple sound wave can bring order to a chaotic stream of water, what other kinds of chaos could we learn to tame? If information truly is a force that we can engineer, what are we going to build with it next?